Acid-base equilibrium could be described as a tug-of-war for a proton. Let's use sodium ethane thiolate and methanol as an example of an acid-base reaction. In this animation, we are only going to use two molecules to help simplify it. A base is a proton acceptor or electron donor. An acid is a proton donor or an electron acceptor. The thiolate ion is the base and will accept a hydrogen or donate its electrons to a hydrogen. Methanol is the acid and will donate its hydrogen or accept electrons from the base. After the reaction, notice the base becomes the conjugate acid and the acid becomes the conjugate base. Now the conjugate base can attack the conjugate acid to form the original acid-base pair. This is the physical process that is occurring in solution, described by the equilibrium equation. The base, the thiolate ion, reacts with the acid, the base accepts the hydrogen, and the acid donates the hydrogen. And then on the other side of the equilibrium, the base has now become an acid, and the acid has now become the base. So it is the bases on either side of the equilibrium that are fighting for the proton. So there's a tug of war for the proton. The base reacts with the acid and accepts the hydrogen. Now the base has become the acid and the acid has become the base. The reaction will go again, and the reaction will keep on going back and forth. So which side does the equilibrium lie on? Who wins the fight for the proton? The stronger base will form the stronger hydrogen bond and leave the weaker acid base in solution. In this example, the equilibrium is shifted to the left because the methoxide ion is a stronger base than the ethane thiolate ion. Notice the pKb of the ethane thiolate is 3.5 and the pKb of the methoxide ion is minus 1.5. So the methoxide ion is a much stronger base. If we look at the acid, the pKa's, the pKa of methanol is 15.5, and for the thiol, the pKa is 10.5. So the thiol is the stronger acid. The equilibrium will shift to the weaker acid-base pair, or the larger pKa and pKb values.